Hey guys, Mr. Munyon here with another lesson. We have 11-1 congruent triangles in the 11 activity 11 trust your judgment. So let's go ahead and jump into activity 11-1. Our learning targets for today with congruent triangles are use the fact that congruent triangles have congruent corresponding parts and determine unknown angle measures or side lengths in congruent triangles. So Greg the carpenter works for a green construction company. The company is building a new recreation hall. The roof of the hall will be supported by triangular trusses like the one shown below. So I'm sure you guys have seen some of these in some houses under construction. We have some triangular shaped trusses here. First one looks a little bit different than the second one, and I noticed like in this area here, the second one and third one are different. Looks like all of these are different actually. Different types of roof trusses they could make. Each of the trusses contain pairs of congruent triangles. Greg's boss tells him that his first job will be to determine the side lengths and angle measures of the triangles that make up one of the trusses. So we have lots of different kind of triangles in each of these trusses. Greg wonders, if I know that two triangles are congruent and I know the side lengths and angle measures in one triangle, do I have to measure all the side lengths and angle measures in the other triangle? Greg begins by examining two triangles from a truss. According to the manufacturer, they're congruent. Because the two triangles are congruent, can one triangle be mapped onto the other? If yes, what is the criteria for mapping? So if they're congruent, then there has to be a congruency transformation to be able to map one onto the other. And most of you guys, I'm assuming, will be able to see that this could just be a reflection across a line perpendicular to CF through the midpoint of CF. So if I had a line going down here that was perpendicular to segment CF, going through the midpoint, I could reflect one triangle across and map it onto the other. So there's clearly a reflection that we could use for this one. Given that I could do a reflection, we should be able to see, without actually having to do the reflection, which pieces, not only which vertices, are going to map from BC, triangle ABC, onto triangle DEF, which vertices line up, but also which sides. Like, where does segment AB on this triangle end up? What does it map onto? So we should be able to tell. Let's go ahead and let's go over here so we can see the whole thing. Figure out which pieces correspond. So segment AB corresponds to DE. Segment D. BC right here corresponds to EF. And AC across the bottom corresponds to DF. Segment DF. And the angles or vertices we could tell as well. So angle A, there's only one angle there, so there's no confusion about which one it is. A would correspond to angle D. B would correspond to angle E. And C corresponds to angle F. Since the original angle, not just the vertices identified, we would need to use the angle label as well. Whoops, I guess that one didn't show up. D. There we go. What is the relationship between segment AB and segment DE? Okay, and how do we know those? Well, if those pieces if the triangles are congruent and those pieces correspond, the pieces are going to be congruent, and therefore the lengths will be equal. So AB is going to equal DE. So if the segments are congruent, which I can indicate with the segments congruent to a segment, then I know that the lengths, if I put AB without the little line above it, that means the length of AB is going to be equal to the length of DE. Same thing with the, what's the relationship between angle B and angle E? Their measures are going to be equal if they line up in congruent, just to check and make sure B and E were corresponding congruent. So the measure of angle B is going to equal the measure of angle E. All right. Hopefully this is, you've probably done this in a previous class, identifying corresponding parts, but just to make sure we know what we're doing and using the actual names and correct notation for these is important. All right. The triangles from the truss that Greg examined illustrate an important part about congruent triangles. In congruent triangles, corresponding pairs of sides are congruent and corresponding pairs of angles are congruent. These are called corresponding parts. Obviously, when we have congruent triangles, it's important that we know which pieces correspond on one triangle to another triangle. So we can write a congruency statement about the whole triangle. Notice we have this symbol here representing triangle ABC. And it says that that's congruent to triangle DEF. So when we hear that two triangles are congruent, we know that everything about them has to be congruent. All the corresponding sides have to be congruent to each other. All the corresponding angles have to be congruent to each other. And in addition to just saying the whole triangles are congruent and knowing that they have congruent parts, the order of these vertices is important because it actually tells us each individual angle that corresponds. If the first letter here is A, that means that it's going to correspond to the first letter D. And segment AB, the length of that has to be congruent to segment, equal length to segment DE. So their lengths are going to be equal. And same thing, C, the last vertex of this triangle, has to correspond to the last vertex. So those angles, I know angle C and angle F would be congruent as well. We write the vertices of the corresponding parts in the same order. This is important because that's a lot of information, that statement right there, that we could use. Or conversely, if we're trying to write down a lot of information, we can identify all that information by just writing the congruency statement, indicating every part of that is congruent. All right, so moving on to the next page. Example. All right. For the trusses shown, Greg wants to know if there are any additional lengths or angle measures that he can determine. Since triangle JKL is congruent to triangle MPN, so JKL is this triangle right here, and MPN are congruent. This means that KL is equal to NP. So notice KL is the last two letters. That's congruent and equal to NP, the last two letters on the other side of the congruency statement. So if NP equals 2.1, oh wait, if KL equals 2.1, NP also has to equal 2.1. Also, the angles are equal, so if I know one of the angles, like if N is 50 degrees, then the corresponding piece for N, K, also has to be 50 degrees. Okay, seems pretty easy. Here we have a couple of triangles. Let's see if we can identify any other parts of this. So here it tells me RST is congruent to, triangle RST is congruent to triangle XYZ. I know which pieces correspond by the statement. So instead of just looking at the picture, I can verify for sure by looking at the statement. So measure of angle X. I go over there, not labeled. Without looking at the other picture, I can actually get this from the statement. What does X have to correspond to? R. Do we know angle R? No. Is there enough information on either of these triangles to determine using like the triangle sum theorem? They have to add up to 180. No, I only know one angle here. I don't know any angles here, so I can't, label any extra angles and then solve for the last one using the triangle sum theorem, knowing it has to add up to 180, so I can't do that. It does say if possible, so maybe it's not possible. I'm going to put not possible on this one. Maybe I should write out the whole thing for this first one here. All right. What about the length of YZ? So I look at YZ right here, and I think that's going to be like the next to longest length. I think it's RS, but how do I know for sure? Look at the statement. YX or XY. So XY does correspond to RS. I don't know that one. Can't figure it out. It's not even a right triangle to use Pythagorean theorem or anything, so I think this one might be not possible. All right, for question C, measure of angle T, not labeled, but T corresponds to Z, so I know that one is going to be 47. And side XZ here, not labeled for me, but I know that X and Z are the first and last letters, so R and T. RT are not labeled as well. So it looks like this one is not possible. Whoops, I think one of these should have been done. Which one did I mess up here? YZ is the last two, ST. Oh, that one should be 15. Thanks for those of you guys who noticed that. I'm pretty sure somebody did. Yeah, YZ right here is the last two, should correspond to ST, so 15 centimeters. All right, well, that was good. We caught that one. On question E, it says both JKL, so must be talking about a different figure here. We don't need that one anymore. Triangle JKL and triangle MNP are equilateral triangles in which the measure of each angle is 60 degrees. Can you tell whether or not these triangles are congruent, and explain? So if I have two equilateral triangles, so JKL, equilateral means all the angles are 60 degrees. And another equilateral triangle where all the measures are 60. And I'm purposely going to draw this one. Is this still an equilateral triangle? Yeah. M, N, P. Can you tell whether or not these are congruent? Well, just looking at the pictures I drew, are they both equilateral triangles? Yes. Each of these angles is 60, 60, 60. Equilateral means equal sides. They're also angular. All the angles are equal. This one over here is 60, 60, 60. They add up to 180. Just looking at them, they don't look congruent because I don't know anything about the sides. To be congruent, you have to have all congruent angles and all congruent sides. Otherwise, they would just be similar. So these are similar, not congruent. All right. So now, take a moment and pause the video here. I want you guys to attempt questions 4 through 7, reasonable questions. And when you're done, play the video again. We'll go over them. Okay, hopefully you guys just attempted questions 4 through 7. If not, pause it, go through that. I'm going to go ahead and go over these. If two triangles are congruent, can you conclude that they have to have the same perimeter? Why or why not? Well, if they're congruent, all of the sides are congruent. So the sum of the sides of one triangle does have to equal the sum of those same three sides on a different triangle. So yes, to be congruent, the corresponding sides have to be congruent. So the sum would have to be congruent as well. Is it possible to draw two congruent triangles so that one triangle is an acute triangle and one triangle is a right triangle? Definitely not, because the pairs of angles would have to be congruent. To be an acute triangle, you have to have all acute angles. And any congruent triangle would have all acute angles. You can't have another triangle that has a right triangle, because then if one of the triangles has a right angle, any congruent triangle has to have a corresponding right angle, and it would be another right triangle. So no, because the angles have to correspond. You can't have an acute triangle with all acute angles correspond and be congruent to a right angle. All right, so I guess I should put no, and the reason is corresponding angles would be congruent. If a triangle has a right angle, any congruent triangles have to have right angles. Number 6, rectangle ABCD is divided into two congruent right triangles by diagonal AC. Fill in the blanks to show the congruent pieces on here. So it actually doesn't tell us on this one a congruency statement. It might help if we came up with that, but let's see how far we can go here. It does make, I think it's pretty visually easy to see which pieces are going to be congruent here. So like we know the definition of a rectangle is opposite side. As a property of a rectangle, opposite sides have to be congruent. Whoops. All right. So I should be able to identify which pieces correspond. So like AB on one triangle, what is it going to correspond to? It should correspond to CD on the other triangle. So if those are congruent triangles, I just need to identify the corresponding congruent parts. What about BC? BC has to correspond to DA, segment DA. BAC. So BAC would create this angle right here. If I trace it out, angle BAC is this angle here. And that looks to be the smallest of the three angles. I have a right angle and then two acute angles. Between these two acute angles, this is the smaller of the two. So looking on the other triangle, I'm pretty sure that would correspond to this smaller one. Of the two acute angles on triangle ADC. So angle BAC corresponds to angle DCA. So then if they're congruent triangles, the corresponding parts would be congruent. Last one is ACB. So for ACB, if I trace that out, I get this angle right here. That is the bigger of the two acute angles, so I put a different number of tick marks, should correspond to the bigger of the two angles on the other triangle. What order did I go in? DCA, so let's do this one. Oops, that's not right. ACB, where's that? ACB should correspond to CAD. All right. Here we don't have a picture, but we do have a statement, so it should make number 7 a little bit easier, just based on, we have this statement here to help us identify where these are. So QR, second and third letters, HJ. So segment QR is congruent to HJ. JG, first and last, so PR. Segment JG is congruent to segment PR. Angle R is the last vertex on this triangle, should be J. So angle J is congruent there. And G is the first vertex on this one, so it should correspond to the first vertex on the other one, angle P. All right, hopefully that one went well. Let's try the lesson practice. Looks like we have 4 questions here of the same type of thing. Find the length of AB. So AB here. Luckily, we have a picture and a statement, the smallest side, or the first two, just to be sure. So DF is the first 2 letters here, so 18. Find the measure of all angles in DEF, is it if that are possible to find. Okay, so angle A corresponds to D, so I know that if A is 39 degrees, D has to be 39 degrees. Measure of angle D. I didn't put the M in front. But I don't know any other angles. Whoops. On either triangle, so I can't use corresponding pairs to identify another angle. And I can't use the triangle sum theorem to solve for a third angle if I knew 2 of them. So I can't solve for any other angles on that one. Number 10, what is the perimeter of triangle DEF? So here, looks like AC. Yeah, I know 2 of the sides. If I knew this third one, I could add them all up. And it looks like DE corresponds to AC, so AC is 33. I can just add those up. So it looks like 33 plus 22 is 55 plus 18, 73. Hopefully that's correct. 55 plus 18 would be 65 plus 8, 73. Yep. And number 11, suppose we have two congruent triangles and XY is the longest side of this. Is it possible to determine which side of triangle TUV is the longest? Yeah, if they're congruent triangles, the longest piece of this has to correspond to the longest piece. So if XY is your longest piece in a congruent triangle at TUV, first two letters are TU. That means the longest piece on triangle TUV has to be TU. All right, because it corresponds on the congruent triangle. Hopefully this is everything you need to know from 11-1. This will prepare you for the activity practice you have at the end of 11-4. Good luck to you guys, and I will see you next time.